Welcome back to my new video. In this video, I'm going to solve another question from the chapter from the book Supernova. So let's start. So in this video, I'm going to solve this question. You see, it's a question from laws of motion, SHM, mechanical energy conservation, everything mixed. So let's start it. There is a light pan connected with a light spring of spring constant 1000 Newton per meter, and there are two blocks of mass 10 kg and 30 kg put on it. The system is in equilibrium. The given system shows in the diagram. The given system is shown in the diagram. Neglect any rotational effect. Rotational effect means 10 kg is this side, 30 kg is this side, so it may rotate this side or this may rotate that side. So we have to neglect this. You have to understand that it will only move up and down. Let's say to take the value of gravity equal to 10, and the first question is number 4. Like this, 5, 6 questions are there. This 6 questions are there. So 3 questions are there. So let's first do the 4. Here if you see, they're saying the fourth question, that is, if 10 kg block is removed from the pan, then the maximum height attained by the 30 kg block will be. Means if I remove this 10 kg block, then what will happen? If I remove this 10 kg block, this 30 kg block will go up, right? Because the spring will lose some weight, so its compression will also release, so it will go up. So after some time it will attain a equilibrium. So like this, if you see the fifth question, it is asking the same thing, but in this question, if the 30 kg block is removed, means in this question this 30 kg is removed. In this question, the 10 kg will go up. So to also attain some equilibrium position because the compression is released. Many of you will say that we'll go by SHM technique. SHM technique means that we'll find the equilibrium positions for both cases. We'll minus them and we'll get the distance between the equilibrium positions, and we know that H equal to 2 into the A, and A is nothing but the displacement. From that, you may think that you can go, but in this case, one very good phenomenon is going on, that is, you see, if 10 kg is removed, this 30 kg is going up, or if you see in this case, this 30 kg is removed, 10 kg is going up. In both of the two cases or one of the two cases, it may happen that when this block is removed, this 10 kg is going up with a speed, and this 10 kg jumps off this light pan. In that case, the motion is broken SHM motion. So in that case, you can't apply that formula H equal to 2A. So, but it may not happen in 30 kg, or it may happen in 30 kg. You don't know in which one it is happening and which one it is not happening. So you can't take any assumption that in 30 kg is more weight, is having more weight, so it will not go up, it will not jump, so it may execute SHM motion. So I will apply SHM in this question, or I will not apply this SHM in that question. So you may say like that, but we can't take assumptions that 30 kg will not jump or 10 kg is not jump. It may happen that 30 kg is also jumping and 10 kg is also jumping. So in this case you can't take SHM to do this question, because SHM can make your question answer can come wrong. So in this case, only one thing that you can do, that is energy conservation. That is energy conservation. If you see, then the initial mechanical energy of this system when 10 kg and 30 kg was there, then if we calculate that, then that will be the energy of the spring. That means if we're taking this compression, this height to be H equal to 0, means if we're saying that this height is our initial height or our mean point. So in this case, it is all having the spring energy, and the compression if you calculate, we know that kx equal to mg, and in our case k is 1000, x we have to find, and m is 10 plus 30, that is 40. Sorry, 40 into g is 10. So x will be nothing but 0.4. I hope you understand. 0.4 meter. So this is the compression in the spring. This is the compression in the spring. The energy will be mechanical energy in the initial mechanical energy. Initial mechanical energy will be half k x square plus potential energy, that is mgh, and in this case we have taken h equal to 0, so this will become 0, so only this will be left, so it will be half into k is 1000 and x is our 0.4, that is 0.16. To calculate this, it will be 500, it will be coming nothing but 80 joule, nothing but 80 joule. The initial mechanical energy in this case is nothing but 80 joule. Am I right? Okay. Now if you see the next page, I will be doing the calculations. After some time, what may happen? That is, after some time, what may happen? This 10 kg block, this 10 kg blocks. Let's remove this. This 10 kg block, when it is removed, this 30 kg will go up. Okay. So in this case, it may go up to this height. I am taking the assumption. So if it is our mean point, then this much height will be our new height. That will, I will take h, new height. So our new height. With this, take this h. Okay. So if this is our h and it is going height of this much, and in this case, if we write the position of this, if this is 0.4 calculated earlier, this is 0.4 meter compression, and this compression, if we want to find if we can find, then we can get this height, but we don't know this compression because we don't know that how much it will jump or how much it will not jump. We may know this compression, compression, but we can't say that this is that this block is not jumping, because we know that we are asked the maximum height. So if it is jumping, then this height, this much will not be the height. The height will be the from where it is jumping, from to where it is jumping. So if you see, then we're taking the compression when 10 kg is removed to be x. Okay, to be x. Now h will be equal to, if this full is 0.4, and the new compression is x, so h will be 0.4 minus x, right? Now if I write the mechanical energy, it will be nothing but the spring energy, that is half k, in the new compression, that is I have taken x square, plus now it is having some height, that is m g into this height. We calculate this. K is 1000 by 2, that is 500, calculated earlier. X we don't know in this case, because we need to find that. And plus mgh. Mgh will be, m is 10 plus 10 is removed. Here 10 is removed, so it will be 30. We know we're asked now in fourth question if 10 kg block is removed, so 10 kg is removed, it will be 30 into 10 into h, that is 0.4 minus x. If we calculate this quadratic, then it will come, and we know that the mechanical energy is conserved in this motion, so the initial mechanical energy was 80, the mechanical energy in this case will also be 80, so you can equate them, that is 80 equal to 500 x square plus 300 into 0.4, 300 into 0.4 minus 300 x. If we calculate this quadratic, then it will come nothing but total will come 500 x square minus 300 x, and this will be 300 and 0.4, it will be 120, and 120 minus 80 will be plus 40. It will be plus 40 equal to 0. Now if I take common, if I take common, if I take common from here, how much? 20. If I take common, if I take 20 common, it will be 25 x square minus 15x plus 2 equal to 0. From here, if we calculate, we will get, if you factorize this quadratic, you will get 25. You can do it easily. It will be 5x minus 1 into 5x minus 2 equal to 0. From here, x is equal to 1 by 5 and x is equal to 1 by 5 and x is equal to 2 by 5. This is nothing but, if you see 1 by 5, that means 0.2, and 2 by 5, that means 0.4. Now 0.4 was our initial 0.4 was our initial compression, so it is not our answer. This is our answer. This we can ignore. So this is the value of x that we are asking for. So if x is 2.0.2, then our h will be nothing but 0.4 minus x. We have taken it earlier. 0.4 minus x, 0.4 minus x. If we put it value of x here, then it will be 0.4 minus 0.2, it will be 0.2, h will be 0.2 meter. Now 0.2 meter means 20 centimeter. So the height to which the 30 kg block will rise when 10 kg block is removed is 20 centimeter. It is the answer of our first question. I think 20 centimeter is there in the options. A equal to 20 centimeter, B equal to 40, C equal to 60, and D equal to 30. So A equal to 20. So our answer will be this. A equal to 20. Now let's do the second question. Now let's do the second and fifth question. In this case, jumping may happen. So if you use SHM, it will not occur. In this case, we will go by the same way we have done in the first case. That the same thing, the 30 kg block is removed instead of 10. In this case, we will do the same calculation, but we will put 10 in place of 30. So if you see, 30 kg block is removed in this case. So initial mechanical energy was 80. It will be equal to the final mechanical energy. Final mechanical energy, we know that height to which it will rise, let the height be h, and the new compression be x. So it will be h equal to 0.4, the initial compression minus the final compression, that is x. So we can get the height of rise, and equal, if we get this, then we can write the mechanical energy equation. It is half kx square, half kx square, kx square, the new compression, plus mgh. Now 80 equal to this 500 k by 2 plus k is 1002, half 500 x square plus m is our, in this case, that 30 kg is removed, so m is only 10. So 10 into g is 10 into height is 0.4 minus x. So it will be 80 equal to 500 x square plus 100 into 0.4. 100 into 0.4, it will be nothing but 40 minus 100x. 40 minus 100x. If we calculate, it will be 500x square minus 100x minus 40 equal to 0. If we take common, it will be 25 x square, 20 common, it will be 25 x square minus 5x plus 2, this is plus 2 equal to 0. Now if we calculate this, if we factorize this, it will be nothing but 5. We factorize this quadratic. I hope you all can do this factorizing quadratic. It will be 5x plus 1 into 5x minus 2 equal to 0. Now from here x will be minus 1 by 2 and 2 by 5. We calculate this, it will be minus 0.2 meter and 0.2 meter and 0.4 meter. So we know that initially the compression was 0.4, so we'll cancel this. Our answer is this much. Now the question is why it is coming in minus. It is coming in minus because we have taken the equilibrium position here, so it is rising above the equilibrium position, means the 10 kg block is jumping. After it is reaching its equilibrium position, the 10 kg block is jumping another 0.2 meter. That's why our answer is coming minus 0.2. If we calculate from here the height, then the height we know it was equal to 0.4 minus x, and 0.4 minus of minus 0.2, it will be nothing but 0.6 meter, or it is 60 centimeter. Height is 60 centimeter in this case. When 30 kg block is removed, the rise in height of the 10 kg block is 60 centimeter. If we see the options, we will see that in this option 5 kg, in fifth option, if 30 kg block is removed, then instead of 10 kg from the pan, then the maximum height of 10 kg block will be 60 centimeter. So option B is correct. Now we have to understand what is they are asking in the sixth question. In the sixth question, if you see they're asking the maximum velocity of 10 kg block when 30 kg block is removed. Now they are not asking the velocity, they are asking the maximum velocity. Now my question is when it will attain the maximum velocity. My question is when it will attain the maximum velocity. If we analyze the motion carefully, then we'll understand. For example, this was the ground, and when all four of them or two of them were there, 10 kg, 30 kg, it was at a height this much, right? Now, when this 30 kg is removed, the equilibrium, the compression was for the initial, when both of them were there, compression was 0.4. Am I right? When this 30 kg is removed, immediately the compression of the spring decreases. So it may decrease to this much height. I don't know at what height it will decrease, but after that, when it is reaching there, the jerk is making this 10 kg block to fly off to another 2 meter. Am I right? So when it is going like this, the equilibrium position, we all know that in SHM, when it is reaching the midpoint, or it is going away from the midpoint, the speed is maximum, and they are asking the maximum velocity. In this case, if this is the equilibrium, then when this 10 kg block is leaving, when the 10 kg block is here, that means when the 10 kg block is going to jump off this surface to attain another 2 meter, another 0.2 meter, that time the velocity will be maximum. When the 10 kg block is reaching its maximum velocity, when it is in crossing its new equilibrium position, new compression, that time it is getting its maximum velocity. Now we have to find when it will, at what point its new equilibrium will shift, at what point its new equilibrium will shift. If you see carefully, the new equilibrium shift means when 30 kg was there, we have calculated by kx equal to mg, it was 0.4, x was 0.4, right? And same way, when mass is decreased by 30, means 30 kg block is taken up, 30 kg block is taken up, this 30 kg block is taken up. That time if you see, kx naught means the distance of here, kx naught will be nothing but 10 into g, because 30 kg is taken off, so the new mass will be only 10 into g is 10, and k was 1000, and then if we take this side 1000, and if we cut all this, then x will be nothing but 0.1. Means if only 10 kg was present, then its compression would be only 0.1. Am I right? So when the block from here 10 kg, as just when the 30 kg is removed, it will reach here, the 10 kg block will jump up, 10 kg block will jump up when it reaches the minimum compression of 0.1. So at this case, it is having some velocity, this 10 kg block, because after this it will rise more minus 2 meter. After this it will rise more minus 2 meter or some meters. So here if you calculate, here we calculate the mechanical energy. Initial mechanical energy, we all know it was 80. We have calculated it first. After this, when we have removed the 30 kg block, then it is rising, 0.4 to 0.1. 0.4 to 0.1 means it is rising 0.4 minus 0.1, that is 0.3 meter. So its new potential energy will be mg into 0.3 plus. When it is rising to 0.1, its compression is also 0.1. Basically, we are calculating the compression only. Kx equal to mg, x is compression. So this compression is 0.1. So that means the spring is having some energy. If it's having some compression, that means it is having some energy. Only half k 0.1 square. And when it is here, it is not ending its motion. After that, it is going some height. That means it is having some velocity, and we have to calculate the velocity of this point. And at this point, we're having the spring energy, we're having the potential energy. At this point, we can also find we also have some kinetic energy. At this point, kinetic energy will be half m v square, and we all know we're calculating the the mechanical energy of this point when the block is going up, and that time the velocity is maximum. So this velocity is nothing but the Vmax that we have to find. I hope you can understand this. What I'm saying. This is Vmax. Now if we put the values, let's first rub these things, because we've calculated x equal to 0.1. If I calculate this, first put this right. If I calculate this, then 80 equal to m was nothing but 10 kg in this case, because 30 kg is removed. So 10, g was also 10, and it was nothing but 0.3 plus half k. Half k means 500. 500 into this 0.1 square means 0.1, right? Plus half mv square. Half mv square max square. Now if we calculate 80 equal to 30, because 3 into 10, that is 30. 30 plus 500 is 0.001 means 5, plus half m is 10, and Vmax we have to find. Let Vmax, I am taking it as V, because I don't have to write too much. This V is basically Vmax, Vm. Now this 35, 80 minus 35, so half into 10, that is 5. half into 10 this is 5 into v square vm square equal to nothing but 80 minus 30 minus 5 means 80 minus 35, 80 minus 35. Okay, now 80 minus 35 means 5v square equal to 80 minus 35, that means 45. Now v square is nothing but 9, or v is equal to plus 3. This plus 3 because the velocity direction I have taken in only in that direction. So it will be, velocity will be plus 3, magnitude of velocity will be plus 3 meter per second. So if you see the maximum velocity of the block when 10 kg of 10 kg, when 30 kg block is removed. When 30 kg block is removed, the 10 kg block is going to an height of 0.1 meter. It's 0.1 meter. It's new compression length, and after that it is jumping some height, and we have calculated the maximum height in the fifth question, that was 60 centimeter. So after that it is jumping some height, that means it having some velocity, and we know in this kind of motions, in this kind of SHM motions, it is having the maximum velocity when it is leaving the ground, because after this its velocity will decrease, and at a point it will become zero, and it will wait for some time until it again come down. So its velocity is only maximum when it is leaving the ground. It is leaving the ground at 0.1. So here the velocity is Vmax, and if we calculate the mechanical energy of this part, it was equal to the initial mechanical energy because mechanical energy was conserved. From here, if we calculate the velocity, it came to be 3 meter per second. So our answer will be option A, 3 meter per second. There are many options. You can mark option A, that is 3 meter per second. I hope you understand this kind of questions. This question is a very important question for Olympiad level and JEE advanced level. If you practice this kind of questions, this questions can be broken and then can come in mains or NEET. So you can practice this kind of questions. Thank you.